Ch1.8, which is going to be some review of order operations. This whole chapter, chapter 1, is a bunch of review of stuff you've learned many times. So we're not going to spend a lot of time on it, and the videos will be pretty quick. It is worth making sure we have everything nailed down, though, because it's all super important for everything that you ever do in math moving forward from here. So today we'll review the order of operations, talk about simplifying and evaluating with an emphasis on exponents and sign numbers. There's two words that come up in math a lot. There's simplify and evaluate. There's also solve. Solve is the third that we'll talk about at a different time. But to simplify, you take an expression and you write it in its simplest form, which, I hate that I use the word simplest in my definition of the word simplify, but I did, so I did. You combine all your like terms, distribute through parentheses, and make sure all fractions are reduced. To evaluate, you're going to calculate a numerical value. It comes out with a result of some sort. You can only evaluate if there's no variables or unknowns. If you just have numbers and symbols. You are simplifying if there are variables or unknowns. Both simplifying and evaluating follow the order of operations, but solving does not. Okay, when you solve, you actually usually do the order of operations backwards. First you simplify, then you solve. We'll talk about that eventually. So we're going to evaluate some of these. These first four problems, first four expressions I'll say, represents one of the biggest mistakes that happens in a math class I've found over the years. The first one is -8 like this. The second one is also going to come out to -8. But it's structured differently. Here, the negative is brought to the power. So -2 times -2 times -2 is -8. Here, you have to do the power first. 2 to the third happens first. Then when you're done, you make it negative. Now, if the power is odd, that's not going to change anything. But if the power is even, it absolutely will. -2 to the fourth is -16 because you're multiplying the 4 2's together and then making it negative. But -2 all to the fourth, where the negative is in there with the parenthesis, is going to come out to a positive 16. You need to be extremely aware and careful of where the negative is with the parentheses and the powers, especially if you try to type it into your calculator. If you ever use a calculator and type this in, you'll get out -16, but what you probably wanted was positive 16. So be aware of that. If the power is even, there's going to be a potential that these comes out positive or negative. If the power was odd, they'll just be negative. When you're simplifying or evaluating, you deal first with any grouping symbol. So you've probably learned PEMDAS, or PEMDAS, or whatever you want to say, where P stands for parenthesis, but the parenthesis is really any sort of grouping symbol. I've heard it's kind of getting reframed into GEMDAS, because it's not just parentheses. It could be parentheses, it could be brackets, it could be the big old fraction bar, and it could be absolute value brackets, among probably other things as well. So you always deal with things that are grouped up first, and you work from the inside to the outside. So don't work from left to right, work inside to outside. I am not going to do 12 minus 7 first. In fact, I'm never going to do 12 minus 7. I can't, because this 7 is multiplying everything in this bracket. And I have to do multiplication before I do addition. So I can't, or subtraction. I can't do 12 minus 7 to get 3. The first thing I do is I deal with this parenthesis. So I'm going to rewrite this as 12 minus 7 times 2 minus 4 times 2 squared. Now that parenthesis has been simplified, and so next I'm looking at the bracket. When I'm looking inside this bracket, I ask the question, okay, what has to be done first? The first thing that has to be done inside the bracket is that power. So it becomes 12 minus 7 times 2 minus 4 times 4, because 2 squared is 4, which is 12 minus 7 times 2 minus 16. So it's 12 minus 7 times -14. My handwriting is getting poor. So that's 12 minus 7 times -14 is -98. And 12 minus -98 is positive 110. Because you subtract a negative, it becomes adding a positive. I really should have just distributed the -7 to make that positive 98 to begin with, but I didn't, so here we are. Okay, so this was evaluating. It was evaluating because I found the numerical result because I had numbers everywhere. This one over here is going to be simplifying because I have variables or unknowns that I can't combine or just turn into numbers. I'm going to follow the same steps, only here I've got to do some distributing. See, I could have, I can't combine x plus 4 any further. There's nothing I can do inside that parenthesis because the x and the 4 aren't like terms. That doesn't become 4x, it just stays x plus 4. But I need to get rid of the parentheses, so I'm going to distribute the negative 5. And that becomes 4x minus 5 times the big old quantity of 2x plus 3 minus 5x minus 20. Distribute the negative 5 to both of those. So now it's 4x minus 5, and I'm going to combine my like terms. There's a negative 3x. And 3 minus 20 is a negative 17. So it's 4x minus 5, but that 5 is being multiplied by negative 3x minus 17. Now I can distribute this 5. A bracket is the exact same as a parenthesis. The bracket doesn't mean anything. We just use brackets so they look different from parentheses. So when they're side by side, it's not so confusing. So now it's 4x plus 15x plus 85, which is 19x plus 85. There, I simplified. I had to combine my like terms, get it down to its simplest form, and you'll agree, I think, that this is much prettier to look at than this. If I were asked to evaluate, like say they told us that x equaled 10, I could go back and plug in a 10 right here and plug in a 10 right here and follow all these steps with all these x's being 10s. That's a fully legitimate option that will work. Here's a much better one. Now that I've already done the simplifying, just plug in 10 at the end. It's going to be 190 plus 85, which is 275. So there I evaluated. Once I knew what x was, it became evaluating instead of simplifying. To be clear, if I was given this problem and from the start they said x equals 10, I probably would have plugged in the 10 first, because then I could just do 10 plus 4 is 14 and negative 5 times 14 is negative 70 and just do the calculations without having to do the simplifying. Okay, I've got 2 more written. I'm going to make up probably 2 more after that also. You don't see problems written like this very often unless it's A, something that's being typed out like in Microsoft Word and they don't have a division symbol or a very good equation editor, or B, it's like a thing online on the internet trying to confuse you. You have to take this right here and think of that as its own fraction, because it is. Okay, 4 divided by 2 plus 3. 3 minus 5 I can just make negative 2. So now it's 4 over 5. Get a common denominator. And you have negative 6 over 5. If you typed this into your calculator, it would spit out the answer of negative 1.2, which is negative 6 over 5. Be aware of the grouping symbol as a fraction. Okay, a fraction is a grouping symbol, so you do stuff on the top and on the bottom separately. That also means that if you wanted to type something like this into your calculator, the way that you typed it in would look like this: parenthesis 2 plus 3, close parenthesis, divided by parenthesis 4 plus 5. The parentheses on top and bottom are very important, because if you just typed in this, 2 plus 3 divided by 4 plus 5, the calculator would think that is its own fraction, as it should. So would you if you just saw that and read that. So put tops and bottoms in parentheses when you type things into your calculator. Okay, next let's talk about absolute value. You probably know that absolute value makes things positive, but what you need to be very careful with is it doesn't make things positive until it's been all the way simplified. That says simplified right there, trust me. So you can't just like take this minus 15 and suddenly make it a plus 15. That's not how it works. You have to simplify everything inside the absolute value, then make it positive. So I'm going to plug negative 2 in for x. This becomes 3 minus 4. All that happened was that x became a negative 2. I'm going to calculate 6 times negative 2. Which is then 3 minus 4 times negative 27. Now, numbers outside the absolute value can't distribute to go inside at any time. The absolute value is like a wall. It's a big old wall that nothing goes inside or out of until you've dealt with the stuff inside. So I'm not going to do negative 4 times negative 27. I have to do the absolute value of negative 27 first, which is positive 27. Notice how the absolute value is gone, and so is the negative. It's now 3 minus 4 times 27, which is 3 minus 108, which is negative 105. Again, notice I didn't do 3 minus 4 ever. I never did 3 minus 4 to get negative 1. Okay, 2 more things to talk about really quick. It says that's it for this chapter, but I actually want to talk about powers. I don't think this comes up in our homework yet, but you can only combine like terms if they have the exact same power. So 2x squared plus 5x squared becomes 7x squared. 3x plus 8x becomes 11x, and negative 10 is just negative 10. But I can't simplify that any further. To be like terms, they have to have the exact same variable and the exact same power. And when I add up these like terms, all that's changing is the coefficient, the number in front. This becomes 8x to the third. Don't try to add the powers. Don't try to add another x's. Just add or subtract the coefficients. Okay, that's all. I was going to talk about adding and subtracting negative numbers, but we should be strong enough with that to not worry about it. That's it for this chapter. We'll do chapter 2 pretty quick as well. It's also a very reviewy chapter. We'll have a test on chapters 1 and 2, and then we'll start moving forward. Thanks. See you next time. Okay, check this out. I've got 2 circles set up, but I'm going to have one of them spin faster than the other. This might be tough for me to get going, but here we go. I want to animate this point. Go. Animate. Start. Display. Animate. Resume animation. Okay, that's not it. I want this point to go faster. There it is. The point on the bottom right is going faster than the point on the top left, but they're both rotating around the same size circle. The point on the bottom right is going around 4/3 times faster than the one on the left, and it makes this kind of cool looking spirograph sort of thing. And it's like, looks like it has 3 dimensions, like it's just a bunch of rotating lines, like a physics, looks like a model of an atom maybe. But whoa, there it goes. For some reason it makes me hungry. I can't explain why that is, but I think most things make me hungry. Just so you know, if you like these videos, I got a lot more. They're covering Algebra 2 trig. I've also got worksheets and curriculum and homework sets and all kinds of things you can look at. There's a link down below in the description. But this is pretty great.